Lab 4 Oscillations. Introduction. In this experiment, a video of a mass attached to a spring was provided, and position data was extracted. These values were then used within Glowscript to create a predicted model for motion. The purpose of the experiment was to compare modeled versus experimental data to see how accurate a model would be for predicting the motion of oscillations. The main physics concepts used were energy principle and Newton's second law. The main results were that the computational model differed heavily from the experimental model. Model overview. Figure 1 represents the energy diagram, while figures 2 and 3 represent position versus time, where 2 is the x position and y is for the third figure. Experiment theory. As previously stated, Newton's second law plays a large role in this experiment. This law relates a force to an object's mass and acceleration. An object's acceleration is caused by its mass and any forces acting upon it. Newton's second law was chosen for this experiment to understand how gravitational force relates to mass and oscillations. This equation can be rearranged and rewritten to give velocity update formula. This velocity then can be used to give position update formula. The various potential energies and kinetic energy formulas are shown, as well as the force equations, as well as Fnet. The assumptions of the model were that only spring force and gravitational force act upon the mass and that the z-axis is not considered. Experiment methods. In this experiment, a video of motion was given and position data was extracted. Glowscript model was then created using the following initial position and velocity vectors. Velocity 0, was chosen as it is assumed that the mass is at rest initially. The system was the Earth, mass, and spring, and hence nothing was in their surroundings. Experiment code. Here are snippets of the code. Kinetic energy and potential energies can be seen in lines 92 to 95, as well as lines 136 to 143. These demonstrate the energy principle. Newton's second law can be seen in lines 123 and 125, where 123 represents velocity update and 125 represents the position update. The initial conditions, such as the ball's initial mass, position, and velocity, can be seen in lines 48 to 52. Results and discussion. The model differs from the experimental motion heavily. The modeled motion is in blue, while the experimental motion is in red. The modeled motion is significantly lower than that of the experimental, indicating that the model is not a good fit for the motion. The modeled motion is underestimated. There may have been errors from calibrating in the video, as well as not taking the z-axis into consideration, which may have slightly skewed any measurements. Discussion. What does it mean? The energy principle is satisfied in this experiment, as all changes in energy add up to make 0. This corresponds to the change in total energy, which is 0. Here in this graph, we can see the orange represents delta E, or change in total energy. If we approximate green plus blue plus red, we can approximate it as about 0. The period calculating from the x measurements was 1.646 seconds, while the period from the y measurements was 1.567 seconds. These values are very similar. However, since they slightly differ, these cannot be used interchangeably and one must be chosen over the other. Conclusion. To summarize, the model was not a good indicator for what experimental motion was. The modeled motion consistently underestimated in comparison to the experimental motion. The energy principle was satisfied in this experiment.